Yes, hello, good morning to all. Welcome to my channel Sri Vlogs Fun and Edutainment. So, students, today we are going to discuss one most important topic of our Unit 4 M.Sc, that is Lagrange's method of undetermined multipliers method to find the maxima and minimum values. Okay, Lagrange's method of undetermined Lagrange's method of undetermined multipliers method to find the maximum and minimum values. Right, students? Let us see the working rule. See, students, here working rule is suppose it is required to find the extremum values. Extremum is nothing but maximum and minimum values. Extremum. Extremum is nothing but one more question. This is very important. So find or what are the extremum values? Extremum values are nothing but maximum or minimum. If a function have maximum or minimum at a particular point, that value is said to be the extremum value. Okay, that means highest value or lowest value. Maximum and minimum values are nothing but highest value or lowest value. So these two values are called as extremum values. Suppose it is required to find the extremum for the function. We need to find the extremum. That means maximum or minimum value for a function f of x comma y comma z subject to the condition pi of x comma y comma z. That means we are given a function clearly and we are given a condition. According to this condition, we need to find the maximum or minimum value or extremum value for the given function. So to find the extremum value for the given function, there are several methods, but we use here in this chapter Lagrange's multiplier Lagrange's undetermined multiplier methods. Okay, so this is the working rule for this method. Step number one. First, we form this function capital F of XYZ. Capital F of XYZ is equals to small f of XYZ plus lambda into pi of x comma y comma z, where this lambda is a constant, right? We generate a function or we consider a function f of x comma y comma z is equals to small f x comma y comma z plus lambda into pi xyz. That means this is the given function to us and this is the given condition to us. We need to write the linear combination of these functions as capital F of x comma y comma z. This is called linear combination. If we write some function plus some constant into other function, we call it as linear combination, right? Now, this function is called the Lagrange's multiplier function or Lagrange's function. Okay. Now step 2. Obtain the equations dou f by dou x is equals to 0. What is dou f by dou x? We need to differentiate capital F with respect to x. That is f with respect to x as well as pi with respect to x gives us dou f by dou x plus lambda into dou pi by dou x. Like that, we need to find dou f by dou y is equals to 0. That means we need to differentiate with respect to y, the same function. Dou f by dou y plus lambda into dou pi by dou y. And dou f by dou z is equals to 0. It gives us dou f by dou z plus lambda into dou pi by dou z equals to 0. Now we need to solve these three equations. Okay, solve the above equations. The values of xyz so obtained will give the stationary point of f of xyz. Okay. 1 minute. We will close this. I will erase this because it is causing some disturbance. Right. Now we clearly see. Hmm. So solving the above equations, we will get the values x, y, z. So this point x, y, z is nothing but a point p of x comma y comma z. Say for example, on solving the above equations, so say we get 1 comma 2 comma 3. Say for example, okay. If you get 1 comma 2 comma 3 as the point on solving the above three equations, these three equations, on solving these three equations we will get the point x comma y comma z. Say the for example this point is we got p 1 comma 2 comma 3, say. Then at this point is called stationary point. Stationary point, what is meant by stationary point? At stationary point the function have either maximum or minimum. At stationary point either function have maximum or minimum. That means it is called extremum point. Okay, stationary point, extreme values, extreme value. Okay, the function may have either maximum or minimum value. Okay, now we need to find that value. To find that value, we can substitute this x comma y comma z in the given function. We will find the maximum or minimum value. Okay, so the only disadvantage of Lagrange's multiplier method is the stationary value of f of x comma y comma z can be determines even without determining x comma y comma z explicitly. This is the advantage, sorry. This is the advantage. That means you can find x comma y comma z explicitly. But disadvantage is the drawback in Lagrange's method is that the nature of stationary points cannot be determined. Nature means either maximum or minimum we cannot determine. We may say that we can say that the function have maximum or minimum value at this point, but we can't say either that function have maximum value or minimum value. We can't say. So this is the disadvantage. And advantage is, what is the advantage? We can find the stationary point very easily in simplest manner we can find. So that is the advantage of the Lagrange's multiplier method. Now we will see one example of this method, then you can easily understand what is the Lagrange's method. Say first problem, find the minimum value of x square plus y square plus z square given that given that given that xyz is equals to a cube, right? So first you need to observe what is our f and what is our pi. So this is our f, not u, this is our f. F of x comma y comma z is equals to small f of x comma y comma z is equals to x square plus y square plus z square. And pi is equals to xyz minus a cube, that is equals to 0. These two are very, very important. Now we are constructing the Lagrangian function capital F of x comma y comma z is equals to, say I considered here u, so you can consider either it is f or u. So I considered it is u, so I am taking in the notation u. Okay, you may consider it as small f also. Okay, no problem. So here I consider it as u, so I am taking it as u. U of xyz plus lambda into pi of xyz. So what is the given u of xyz? X square plus y square plus z square plus lambda into xyz minus a cube. Now we need to differentiate with respect to x. So dou f by dou x, that is dou u by dou x plus lambda into dou pi by dou x. I think all you know that partial differentiation we are doing with respect to x. What is the partial differentiation of x square plus y square plus z square with respect to x? Can anybody? Yes, right, exactly. So where is x? We need to search out. Here it is x because we are doing partial differentiation with respect to x. So we need to differentiate the x terms only. The remaining terms treated as constants. In partial differentiation, if we do differentiation with respect to one independent variable, the remaining independent variables are treated as constant. That is the basic formula of or basic rule for partial differentiation, right? So we are doing differentiation with respect to x. So the differentiation of x square is 2x. Right, students, and y square treated as constants, therefore y differentiation is 0, z square differentiation is 0, so I have written here 2x plus lambda remains same. Dou pi by dou x, I need to differentiate this function. That means yz is a constant, so take out yz because it is in the multiplication, so write yz as it is, and the differentiation of x is 1, therefore here yz remaining term, okay, lambda into yz, that is equals to 0. A cube. A cube is clearly a constant. Therefore, differentiation of constants is equals to 0. Now, with respect to y, same we will get 2y plus lambda into xz is equals to 0. I think you will understand. Y square means 2y. Lambda into y differentiation 1. Therefore, lambda into xz is equals to 0. This is with respect to y. Okay, students. Now, dou u by dou z plus lambda into dou pi by dou z. Z square differentiation is 2z, and with respect to z differentiation is 1, therefore xy into 1, that is equals to 0. Now, solving these three equations, we form a relation in xyz, and we will get the xyz value in terms of some fixed point, right? In terms of some fixed point. It is very, very important. How do we find the xyz values in terms of fixed point? Now we will see. Now, taking fourth equation, I am considering this fourth equation. What is the fourth equation? 2x plus lambda into yz is equals to 0. So you can write it as 2x is equals to minus lambda into yz. I am cross multiplying this yz, so I get it as x by yz. X by yz is equals to minus lambda by 2. Now taking the fifth equation, 2y plus lambda into yz is equals to 0. 2y is equals to minus lambda into xz. From this equation, I am writing this, okay? So 2y is equals to minus lambda into xz. That is equals to, we are cross doing the calculation part. 2y is equal to minus lambda into xz gives us y by xz is equals to minus lambda by 2. Now taking from the sixth equation. So from the sixth equation, what I can write? 2z is equals to minus lambda xy, z by xy is equals to minus lambda by 2. Okay, clear? So this is minus lambda by 2, this is minus lambda by 2, this is minus lambda by 2. What it means? All are equal. Okay, so x by yz is equals to y by xz is equals to z by xy is equals to minus lambda by 2. Now from these equations I am taking the first pair. This is the first pair I am taking. X by yz is equals to y by xz. I am taking the first pair of equations. Okay, x by yz is equals to y by xz. Now x by yz is equal to y by xz. Z get cancelled. X into x, I am doing the cross multiplication. X into x is equals to x square. Y into y is equals to y square. Okay, so x into x is equal to x square. Y into y is equal to y square. We can also write it as x is equals to y. Okay, here only we can write x is equals to y. It gives us x is equals to y. Clear? X is equals to y. Now same as we am taking the second pair of equations. Second pair of equations are y by xz is equals to z by xy. From the second pair of equations, x get cancelled, y into y again cross multiplying, y into y is equals to y square, z into z is equals to z square. So here only I can write it as y square is equals to z square gives us y is equals to z. Y is equals to z. Okay, students. So x is equals to y is equals to z. What it means that x is equals to y is equals to z. Okay, we got the relation x is equals to y is equals to z. Now from this we need to find the value of x, y, z in terms of constants. So in terms of constant means we must use the condition here. What is our condition given x, y, z is equals to a cube? Always one function and one condition given to us in the given problem. Okay, using that condition we can find the values of x, y, z in terms of constant, right? So x is equal to y is equal to z, we substitute in the condition, then what we get in the place of y also we can substitute x. In the place of z also we can substitute x. So x into x into x. X into x into x is nothing but x cube. X cube is equals to a cube. Therefore, x is equals to a. So if x is equals to a, all we know that x is equal to y is equals to z. Therefore, x is equals to y is equals to a. X is equals to y is equals to a. This is our stationary point. That means at this point we have either maximum or minimum. So the point we got here, the stationary point we got here is P of x comma y comma z is equals to a comma a comma a. Right, students? That is equals to a comma a comma a, right? So the function have maximum or minimum at this point, a comma a comma a. So what is our function according to our assumption? I considered it as u. Therefore u is equals to x square plus y square plus z square. So a square plus a square plus a square, that is equal to 3a square. Therefore the in the question only it is given that find the minimum value, because this is the disadvantage in the Lagrange's multiplier method. We can't find either the function have maximum or minimum value. Just you can find the stationary point. Okay, as we discussed earlier. So in the question only it is asked that. That's why in the question only it is asked either we need to find minimum value or maximum value. Clearly in the question is given minimum. So the minimum value of f according to the given condition is 3a square. 3a square. Is it clear, all of you students? Right. Now we will see one more problem, students. Find the maximum value of f of xyz is equals to x square y cube z to the power of 4. Okay. According to the condition or given condition, 2x plus 3y plus 4z is equals to a. So here also I have considered small f as u. Therefore, u is equals to x square plus into y cube into z to the power of 4. The given condition pi of xyz is equals to 2x plus 3y plus 4z minus a. Now, according to our Lagrange's multiplier method, we need to form the Lagrange's function f capital F is equal to u plus lambda pi. Therefore, in the place of u, x square y cube z to the power of 4 plus lambda into pi, 2x plus 3y plus z minus a. Now we need to differentiate with respect to x. X square differentiation 2x y cube and z power 4 remains the same because constants. Constant into differentiation of x square plus 2x differentiation is 2 and 3y is only constant, differentiation 0, z constant 0, a constant 0. So dou f by dou x we got that 2x y cube z power 4 plus lambda into 2. Now we need to equate it to 0. Dou f by dou x is equals to 0. So xy cube z to the power of 4 is equals to minus 2 lambda, 2 get cancelled. So we get it as xy cube z power 4 is equals to minus lambda. Similarly, we get x square y square z power 4 equals to minus lambda. Doing in the same manner, partial differentiation with respect to y, we get it as x square y square z power 4 is equals to minus lambda. In the same way, we get x square y cube z power 4 is equals to minus lambda. Now here also minus lambda, minus lambda, minus lambda. What it means, all are equal. So we are constructing a relation. First is equals to 2 and second is equals to 3. Okay, na? So we are taking the first pair first. These equations. X y cube z power 4 is equal to x square y square z power 4. From this we got y is equals to x. And we are taking the second pi. What is the second pi? X square y square z power 4 is equals to x square y cube z cube. That is equals to z is equals to y. That means x is equals to y is equals to z. It also gives us x is equals to y is equals to z. Now substitute these values in the condition. We get 2x plus, in the place of y also we need to substitute x. So 3x plus 4x, that is equals to a. So 9x is equals to a, x is equals to a by 9. So x is equal to y is equal to, already we know that x is equal to y is equal to z, therefore x is equal to y is equal to z, that is equal to a by 9. So the stationary point is here a by 9 comma a by 9 comma a by 9. Okay na? Therefore, at this point, the function has maximum or minimum value. So, the maximum value is, we need to substitute this a by 9 in the given function, because it is already given that in the question only it is given that find the maximum value. Therefore, the maximum value is a by 9 whole square into a by 9 whole cube into a by 9 whole to the power of 4. That gives us a to the power of 9 by 9. Clear? Now, students, these two problems please do at your own. I think this problem is very easy. This is also easy. Condition according to condition. Okay, now this type of problems may also ask in the examination. This is the what type problem. Find the points on the surface. Find the points on the surface. That means we need to find a point on the surface. What is the surface given to us? Z square equals to xy plus 1 that are nearest to the origin. Nearest to the origin. That means here condition is given to us. According to what condition we need to find the point? We need to find a point such that on the surface, we need to find a point in this surface. Okay, the point should lies on this surface, and that point should be nearest to origin. So using this condition, we need to find the function. So we are considering our required point is p x comma y comma z. Consider our required point is p x y z. Now, according to the given condition, this point satisfies two conditions. One, this point lies on this surface, and the second condition is this point is nearest to the origin. That means the distance between these two points, that means origin and this point, is minimum. That is okay. So now I am taking the condition as pi of x comma y comma z, that is equal to z square minus xy minus 1 is equals to 0. And according to the given data, the point is nearest to the origin. Origin is nothing but O0 comma 0 comma 0. Okay, I can find the distance between these two points. O0 comma 0 comma 0 to the point on the surface P is x minus 0 whole square plus y minus 0 whole square plus z minus 0 whole square. I think all you know that the distance between two points is x1 minus x2 whole square plus y1 minus y2 whole square plus z1 minus z2 whole square. So according to that, we get OP is equals to root of x square plus y square plus z square. According to our convenience for calculation, I am taking OP square as f. Okay, because if root is there, the differentiation is somewhat difficult. So to remove the root term, I am taking OP square, because there is no difference in maximum and minimum value if we square the value. So that I am taking, for our convenience, f is equals to OP square. So x square plus y square plus z square. This is our function. F is equals to OP square, x square plus y square plus z square. Now I am constructing. The problem is same as earlier now. Now I am constructing, or I am considering the Lagrange's function capital F is equals to x square plus y square plus z square plus lambda into z square minus xy minus 1. Now taking the differentiations, partial differentiations with respect to x, partial differentiation with respect to y, partial differentiation with respect to z. Dou f by dou x is equals to 0. So I get this equation 2x minus lambda y equals to 0. So on equating dou f by dou y is equals to 0, I got 2y minus lambda x is equals to 0. And equating dou f by dou z is equals to 0, I got z into lambda plus z is equals to 0. Okay. What is dou f by dou x here? X square differentiation is 2x. Z square 0, xy differentiation is with respect to x1, therefore minus lambda y. Here 2y minus lambda x, and with respect to z is 2z. Here 2z is also there. 2z lambda z is equals to 0. So z is equals to 0. So we got z is equals to 0. Z into 1 plus lambda is equal to 0, nothing but z is equals to 0 and lambda is equals to minus 1. But z not equals to 0. What happens if z is equals to 0? Why we are not taking z is equals to 0? If z is equals to 0, then the surface xy plus 1 is equals to 0. It is not a surface, then it turns to be a two-dimensional space. Xy plus 1 is equals to 0. Xy is equals to minus 1. So we can't take z is equals to 0. Okay. It changes to two-dimensional space. So z not equals to 0. So what we consider? Lambda is equals to minus 1, right? So substituting lambda is equals to minus 1 in 4 and 5 equations. Lambda is equal to minus 1 if I substitute in the fourth equation. What is the fourth equation? What is the fourth equation, sir? Yes, here it is. 2x minus lambda y equals to 0. So in this equation, I am substituting lambda is equal to minus 1. So minus into minus plus 2x plus y is equals to 0. Like that, I am substituting in the fifth equation, minus into minus plus x plus 2y is equals to 0. So we need to solve these two equations. 2x plus y is equals to 0 and 2y plus x is equals to 0. Right, sir? Now on solving, because these two equations are passing through origin. So when the equations passing through origin, always 0 comma 0 is the solution. Okay, 0 comma 0. That means x comma y is equals to 0 comma 0. Now put x comma y is equal to 0 comma 0 in equation 1. We get z square is equals to 1. So z square is equals to 1. That means z is equals to plus or minus 1. Okay, x is equal to 0, y is equal to 0. I am substituting in the given equation. Z square is equals to xy plus 1. I am substituting in this equation. So z square is equals to 1. So z square is equals to 1 gives us z is equals to plus or minus 1. Z is equal to plus or minus 1. So the required points are 0 comma 0 comma 1 or 0 comma 0 comma minus 1. If he asks what is the maximum value of the function, means we need to find, we need to substitute 0, what is the nearest value. Now we need to substitute 0 comma 0 comma 1 in the given function, that is root 1. Right, students? Okay, I hope this video is understood for you, this concept Lagrange's multiplier method. So I have given some more problems. This is also very, very important. Find three positive numbers whose sum is 100 and whose product is maximum. Find three positive numbers whose sum is 100 and whose product is maximum. Right, sir? So I am taking x, y, z. These three numbers are some positive numbers, and clearly the condition given is sum is sum is 100. So I am taking the sum as 100, and the product is maximum. So I am taking the product as f of f is equal to x comma y, x into y into z. Product means x, y, z. So taking the Lagrange's function and differentiating and equating to 0, and I am getting the same condition, x is equals to y is equals to z. Okay. Now substituting this x is equals to y is equals to z, x is equal to y is equal to z in the given equation, in the given condition, I am getting the value. So this is very, very important. So one problem is there, a rectangular box open at the top is have volume of 32 cubic feet. Find the dimensions of the box requiring least material for its construction. So rectangular, open rectangular box of 32 cubic centimeters, that means volume is given for the rectangular box, that is equal to 32. XYZ is equals to 32 volume formula. So this is our condition, and open rectangular box, so top only is there, the bottom is not there, so we can take it as only xy plus 2yz plus 2zx. So the for the remaining sides, top and bottom is there, only for one side top is not there. Okay, so this is the problem, and you can do now in the previous method. Okay, thank you, students. Thank you for listening this. Thank you very much.